The hyperbolic functions sinh of x and cosh of x are defined as sinh of x equals e to the x minus e to the negative x all over 2, and cosh of x equals e to the x plus e to the negative x all over 2. Tanh of x is defined as sinh of x over cosh of x, and we can use the definitions of sinh of x and cosh of x to define tanh of x in terms of exponential functions. Hyperbolic functions are considered to be analogous to trigonometric functions, and notice how tanh of x being defined as sinh of x over cosh of x is similar to how tangent of x equals sine of x over cosine of x. So we can also define the reciprocal hyperbolic functions, hyperbolic secant, hyperbolic cosecant, and hyperbolic cotangent. They're analogous to the secant, cosecant, and cotangent functions respectively. One way to pronounce them is secant h as sech, cosecant h as cosh, and cotangent h as cosh, but there are other ways to pronounce them for sure. So now what we're going to do is define sech of x, cosech of x, and cosh of x in terms of exponential functions. So sech of x is defined as 1 over cosh of x, and since cosh of x equals e to the x plus e to the negative x all over 2, we can rewrite 1 over cosh of x as 1 over e to the x plus e to the negative x all over 2. And we can simplify this complex fraction by multiplying both the numerator and denominator by 2. So this just equals 2 over e to the x plus e to the negative x. So this is the definition of sech of x in terms of exponential functions. Sech of x is just equal to 2 over e to the x plus e to the negative x. Cosech of x is defined as 1 over sinh of x, and since sinh of x equals e to the x minus e to the negative x all over 2, we can rewrite this as 1 over e to the x minus e to the negative x all over 2, and if we simplify the complex fraction by multiplying both the numerator and denominator by 2, this just becomes 2 over e to the x minus e to the negative x. So cosech of x is equal to 2 over e to the x minus e to the negative x. Cosh of x is defined as cosh of x over sinh of x. So we can use the definitions of cosh of x and sinh of x to rewrite this as e to the x plus e to the negative x over 2, which is the definition of cosh of x, and this is all divided by e to the x minus e to the negative x all over 2, which is the definition of sinh of x, and then if we multiply both the numerator and denominator by 2, this is just equal to e to the x plus e to the negative x over e to the x minus e to the negative x. So cosh of x equals e to the x plus e to the negative x, all divided by e to the x minus e to the negative x. So here's what the graphs of these reciprocal hyperbolic functions look like. Sech of x lies entirely above the x-axis and approaches the x-axis asymptotically from above as x approaches positive infinity and negative infinity, and has a maximum value of 1 when x equals 0. It's also an even function. Cosech of x approaches the x-axis from above as x approaches infinity, and from below as x approaches negative infinity. The value of cosech of x also approaches infinity as x approaches 0 from the positive side, and approaches negative infinity as x approaches 0 from the negative side. The function is undefined at x equals 0. It's also an odd function. Cosh of x asymptotically approaches the line y equals 1 for positive x values and approaches the line y equals negative 1 for negative x values. So the function is not defined for x equals 0, and the range of the function is y less than negative 1 and y greater than 1. It's also an odd function. So to recap, the reciprocal hyperbolic functions are defined as sech of x equals 1 over cosh of x, cosech of x equals 1 over sinh of x, and cosh of x equals cosh of x over sinh of x. Cosech of x and cosh of x are not defined for x equals 0, and that's because when x equals 0, the denominator of the expression which defines the functions would be 0, and division by 0 is undefined. We can also define these functions in terms of exponential functions using the definitions of sinh of x and cosh of x.